lines of source code includes blanks, comments, everything like that. Okay? Now, how to read it. Obviously, higher number indicates more code, lower number indicates less code. Okay. And, all right, what it can tell you. So it's going to help you identify large files or bloated classes. What it can't tell you is whether or not the code actually works. So that is, I'd argue that's one of the important things that you need to know when you're actually writing your code. So the takeaway from this is you want to use it to spot trends, not to judge productivity. Okay? So let's switch over to Visual Studio. And all right, so I'm going to show you real quick how to generate code metrics using Visual Studio. So you go to, it's, everybody's staring at me now. So. Now you do it. All right, so we're going to run code analysis on the solution. And it says it should be complete. Sorry, we're going to do calculate code metrics for the entire solution. Okay. There we go. Let's make this a little bit bigger so we can have something to point at. We're going to look at the output file validator first. And this little, I hope you can see it, but this little window down here at the bottom, it gives you a bunch of code metrics for all the different projects in the solution, and then inside the projects it breaks it down by class and then by methods and that kind of thing all the way down. So we want to look at okay, this is what I was looking for. Let's pull this up a little bit. Okay, so just looking at this constructor here for the output file validator. How many lines of code does that have?
4.
Right, 4. Remember, because you counted every line of code, you're not excluding comments, you're not excluding blank lines. So, now that we've seen that, that's exciting. Go back to here. So we're going to move on to our next one, which is the lines of executable code. All right, that's going to be number of executable lines in the code base, not including comments or white space, like you were saying. Right?
So it's delimiters.
Huh?
But this would include delimiters still. Or
What do you mean delimiters?
like opening braces, closing braces, stuff like that.
Yes. No.
Okay.
So it does not, and I'll show you that in a second. So it's often used as crude proxy for size or effort. How to read it, higher number indicates more executable code. Lower number indicates less executable code. So what it can tell you is going to tell you the relative size of modules or functions. And it's going to give you a much better idea of that because it's not including comments and blank lines and things like that. And it's also going to tell you when something is likely too large or sprawling. Every now and then you'll come across some of these monster classes that makes you think nobody was actually paying attention to the code metrics at all when they were writing the code. So it's also helpful for identifying hotspots that may need refactoring. So what it can't tell you, it's not going to tell you anything about the code quality, nothing about the maintainability, or anything about the developer productivity. And it's not going to tell you whether it's well tested, readable, or even correct. So takeaway for this is you want to use lines of code or lines of executable code as a signal, not a score. More lines do not equal more value. All right, so we're going to come back over here. And remember we said that there were 4 lines. This has 4 lines of source code, but the lines of executable code in here is, let's go to it. Has 1. There's 1 line of executable code in that method, and that's it right there. So, dirt simple, right? It gives you a much better idea about the complexity of this particular method. All right. So, moving on to our next one. Class coupling. Anybody know what class coupling is?
When one class depends on the other, or not using interfaces.
Kind of. So, what's that? So that's kind of related to it, okay? So we need to define a couple terms before we go into this. First one is coupling, okay? That's going to be the degree of interdependence between software modules. So that's going to be like if you're, if you inherit from a base class, or you're using a class that's defined in another class somewhere else, kind of thing. So coupling is not binary, but it is multiple dimensional. So there's 2 ways to describe coupling. Low, also known as loose or weak, and high, also known as tight or strong. So if something is loosely coupled, that means that there is, I'm trying to remember, make sure I get it right. So if it's something that's tightly coupled, that means you have a lot of classes that are all involved in that one class that you're looking at. If it's loosely coupled, it means that it probably only has the classes it needs to get the job done. All right. Now the next one here is low coupling often correlates with high cohesion. So the next question you might have is, what is cohesion? So cohesion is the degree to which elements inside a module belong together. Okay? So there's 2 ways to describe cohesion. High, which means elements are related, strongly related, and they have kind of like, it's focused on a well-defined purpose. Then you have low cohesion, which means the elements are loosely related and serve multiple purposes. All right, so now back to the code metric we're talking about now, class coupling. That is a measure of how many classes a class depends on. Okay? So the more dependencies, the more coupled it is. So if you end up using NuGet packages and you're pulling in code from outside your code base, that's a dependency. That's going to make your class coupling metric go up. So how to read it, 0 to 5, low coupling. So likely modular, easier to test and reuse. We want code that's easy to test and reuse. Okay? If it's 6 to 10, that's moderate coupling. And if it's 11 plus, it's high coupling. And that's going to occur in cases where you have like a God class. Just a class that just knows too much, right? Or has too much responsibility. So if we're good developers and we're following solid principles, this kind of speaks directly to the single responsibility principle. So it's an S and solid. So what I can tell you, high coupling is more difficult to test, maintain, reuse, but you can use this to spot design smells like God classes if you have tight integration or hidden dependencies. What it can't tell you is whether those dependencies are necessary or well abstracted, right? So it's also not going to tell you whether or not you wrote the right code either. Although one thing I will say is that sometimes tightly coupled code is perfectly valid. So you're going to use that in cases where you're like mapping between objects and things like that. That can drive up the class coupling. So the takeaway Low coupling is the dream. High coupling is tech debt with a LinkedIn account. Now let's go look at class coupling. So let's go look at input file validator, input file generator. So this has 10 in it, or has class coupling of 10. So you can see we're using a bunch of different classes that were not actually written in this particular class. So that's all your file streams, parallel queries, binary writers. Yeah, so there's a bunch of stuff that gets pulled in here.
So would that include like external packages, dependencies?
Yeah. Yeah, so so this is one of the downsides of using this code base for as an example. I didn't use a lot of NuGet packages with it back then, so I think the only NuGet packages that were actually used in this particular solution were for the unit tests and the performance tests. So I use XUnit for the unit test, and then I pulled in benchmark.net for the performance tests. So that tells you the
Yeah, I could agree.
it's telling you about the integrate the type. Is it type?
It's a scale, it's not a number of classes.
Right. Yeah.
No, I don't think so. It's a scale, because here also it's like the number. The number is just continues to grow as the.
Yeah. The more complex your code is, the more.
Like 1 to 100 or something.
Yeah. Well, I don't know. Let's go through and count. Let's do that. So let's see. We have random file stream, file, binary writer, parallel query, maybe enumerable. That gets us up to 6. Yeah, we can also look at one that has class coupling of 0. So, all right, so going back to that, the constructor for output file validator, this has 0 class coupling in this method, right? Because it's just using string. It's simple. But the method below it, validate, has 5. So, file stream, binary reader, file.
So framework classes are not like counted in these methods.
No, they're counted.
Yeah.
So that might be what I'm missing is,
There's external for
yeah. So string and int. Oh, there's end of stream exception. Those all come in from outside this particular class. All right. Depth of inheritance. So your family tree, but with more bugs. So now we're starting to get into the argument of composition over inheritance. If anybody's ever had that before. So it is the number of inheritance levels from the class to the root of the hierarchy. All right? And when I say hierarchy, types in .NET, it can be represented on a tree. And the root of that tree is object. So that means that everything in .NET inherits from object. So that you box and unbox. You can cast to and from object. It's called boxing. So if you don't know, typically you don't want to do that because that's a place where you can hurt performance. That's what you're writing. Sometimes you got to do it, but try not to do it. All right. So it's telling you where the class actually sits in the inheritance chain. Right? So if you have a class, let's say A, and that inherits from B, and that inherits from C, the depth of inheritance for A is going to be 1, B is going to be 2, and C is going to be 3. Right? Anybody know why A has a depth of inheritance of 1?
Child.
Is what?
Child.
It is, but of what?
Object.
There you go. Bonus points to you. All right, so how to read it? Lower number for depth implies less complexity, but also the possibility of less code reuse through inheritance. Right, so the point this is making is when you have really deep inheritance, it opens the door for like a bunch of cracks in your code where bugs can creep in. Right? So a high number of for depth, so that means you're inheriting from more classes. So you have a greater chance of code reuse through inheritance, but higher probability of errors in the code. All right, so what it can tell you is high depth in inheritance implies greater reuse, but also greater complexity. Because there's a lot more that you have to start putting in your brain whenever you want to use it. Right? So it may also indicate classes that are too tightly bound to framework or fragile base classes. And they tend to be harder to understand and test, right? Because if you have to go through and understand the entire type hierarchy for your object, and you have to write a unit test for it, that's a lot of stuff that you're responsible for testing, right? If you're going to do good tests. Right? All right, so what it can tell you is whether inheritance is used appropriately, right? It's not going to tell you if the base classes are clean or a mess. And I've seen some base classes that are just, that's why people leave companies. I think they make so much of a big mess that they just kind of box themselves into a corner, and then the only way for them to get out is to leave a company or be tossed out, depending on the situation. And also whether or not your object model makes sense. So the takeaway, this is the favor composition over inheritance. So you want to favor shallow hierarchies. If you need to scroll more to trace your class and lineage, it's probably time for a rethink. Okay. All right, so this one is one of my favorite. This is probably, this is one of my top 2 favorites that I'm going over tonight. So cyclomatic complexity. Oh, wait, hang on, before we get to that.
So in your professional work, what's the maximum inheritance depth you've gone to?
Okay, so depends on whether or not you're actually keeping track of metrics as you go. So, but that is a good question, and I have an answer for that. So here, this is my blog, Code Gorilla, codegorilla.com. But this was some metrics I got a few years ago from one single class in a code base. And I don't know if you can actually read it, but the lines of code in that, there's over 61,000 lines of code in this one class. Wow. So the class coupling for the class is 3,617. This thing is not following the single responsibility principle. This is more of a God class, right? It knows too much. And yeah, so I won't talk about cyclomatic complexity and maintainability index because I'm going to get to those. But so this is probably one of the worst ones I've seen. And so here's the top 3 methods in that class, right? The class coupling on the first one here is 77. There's 77 classes in one method. There's 62 in position 2 and 27, and more reasonable 27 in the third.
So if you have like this big God class. I mean, the inheritance levels for that project would be very shallow, I guess, because everything is there in the main class, and if there's any inheritance, it would be maybe one level down.
Well, this one, depth of inheritance on this particular class is 2. So object, and then there was another class, another base class in between. So this one's very broad. It's not very deep. All right. Go back. All right. So we're going to show depth of inheritance. So let's find one that's okay. So I don't really have a good example of depth of inheritance for you in this solution. The depth of inheritance for everything is 1, right? And that is not because I don't like inheritance. It's more because this was just it was kind of a coding assessment, right? So you're writing the code to get the job done to hopefully move forward in the interview process. Okay. Now we're moving on to cyclomatic complexity, one of my two favorite metrics that we're going to cover today. So how many ways can this go wrong? So it's a measure of the pass through the code, right? So if you have like the constructor on output file validator that I showed a little while ago, what's the cyclomatic complexity of that? 1. There's one way you can go through that code. If you add an if statement in there, congratulations, now you've got a cyclomatic complexity of 2, right? So let's keep going. So as I was just saying, it's calculated on decision points. You can do it with ifs, fors, any of those. Higher numbers are bad, right? Lower numbers are good. And so it's going to tell you about the logical complexity of a method or function. Higher values often suggest that the class is going to be more difficult to test. Remember the metrics I just showed you before? Let's jump back to that real quick. Okay, cyclomatic complexity on that class is 9,529. There are 9,529 possible paths through that code. And you're going to write a unit test over even if you got 80% of that, it's insane.
That's for all the functions within the class, or?
Yeah, it's just for that class. Boom. All 61,900 lines of code. Oh wait, sorry. It's 61,900 lines of code. So that includes any comments. There weren't a whole lot of comments, and it's including all the curly brackets and stuff like that all over the place. All right, and then let's go to the methods. So cyclomatic complexity on this third one down here is 284. This one method has 284 ways that you could possibly execute it, right? So obviously,
So 284 potential test cases or different parameters for each execution.
yeah, if you wanted 100% code coverage, yes.
I mean, that's defeats the purpose, I would think.
It starts getting into where you actually need to look at the code and let it bog your computer down, which it did. So that should never happen. I mean, sometimes it's going to, but it should be few and far. It's just a bad idea to write code that complex.
And that's what you focus for that one method. If you're trying to actually unit test a class, you have to do 10,000 test cases if you want full code coverage.
You know what else makes that difficult is if you're unit testing, right? Typically, you're only going to unit test all the public API, all the public methods. You know, public methods, properties, all that stuff. Just going to do that. So it's basically you're testing for where it enters that particular method in the class and where it exits. And then from there you have to get all your different test cases. Depending on how militant your team's coding standards are, I guess. All right, so it's also more difficult to maintain, right? I think I made a good point with that. The cyclomatic complexity over 9,000, you can't keep all that in your head. Okay? We didn't have ChatGPT back then, but that might have been fun to feed that in, just to see what it does. So it's going to also suggest what needs to be refactored or split out. All right, so what it's not going to tell you though, it's not going to tell you whether your code is bad, just if it's complicated or not, right? It will not tell you anything about how well structured your logic is or how readable it is. I guarantee you that class with over 9,000, cyclomatic complexity over 9,000, was not readable. I mean, it was, but you'd have to stare at it, a long time until you actually kind of figured it out, scrolled up and down. Don't write code like that. I got scars from that somewhere. It's not going to tell you whether or not the method is complex because the requirements not bad design. So, the takeaway for this is to keep it under 10 if you can. When cyclomatic complexity hits 20 plus, maybe your function needs therapy. That class I showed you a little while ago needs a boatload of therapy. It's atrocious. So let's look at some of the cyclomatic complexity we have in this particular solution. Let's see, what's the worst one? All right, external merge sorter. Okay, this is what's actually doing, I can open it up here. This is this is what's actually going to do the bulk of the work, right? So this doesn't load anything, it doesn't write anything out to disk. It basically just does the sort, right? So this constructor has a cyclomatic complexity of 2, 4, yeah. So the cyclomatic complexity of that should be 4. Let's see, confirm. Nope, 3. Okay. This is why you use.
Because first statement throws exception, so second will not be executed.
Yeah, this is why we use tools to kind of crunch these numbers, and you're not going through a calculator, adding everything up by hand. I'd still be counting if I had to calculate the cyclomatic complexity on the numbers I should have shown. Okay, got that. All right, Maintainability Index. I like this one too. We're going to math up our code quality, right? So this one actually has a formula that Microsoft uses to generate this metric. If you know what it is offhand, I'll be surprised. But if not, I will tell you. Composite metric tries to quantify how maintainable a piece of code is. So it is based on cyclomatic complexity, lines of code, the Halstead volume. Anybody know what Halstead volume is?
I think I remember hearing that somewhere, reading about it somewhere, but I don't recall. Did it have something, was it related to psychology?
No.
Okay, maybe I'll remember.
So there's a bunch of Halstead metrics. So the whole topic of code metrics, it's kind of an iceberg, right? So there's the code metrics that we see at the top, which are kind of the ones I'm going through right now. But underneath all of that, there's a whole bunch more. And I don't have enough time to go through all that here in about an hour. So anyway, the Halstead volume is a metric that tells you about the relation between an operand and operators, or operands and operators. So and sometimes common ratio. So Microsoft uses color-coded ratings, so it can tell you how quickly It can be used to identify trouble spots in your code quickly. So green is usually between 20 and 100. Yellow, 10 and 19. And red, we need to have an intervention. And I wish I would have gotten the maintainability. Oh, I do have the maintainability index for those metrics we were looking at a while ago.
For that big dog class, because I remember the index was 0 across the board.
Yeah.
Yeah.
So maintainability index is 49. I think that's probably being generous in this
Yeah.
particular class.
Because the methods are all like 0 across the board.
Yeah. Yeah, so this is just, God, all right. So it gives you a quick snapshot of overall maintainability. It's useful in dashboards to track regressions and quality over time. It's going to tell you, it can't tell you why the score is low. So you'll have to dig into the components that make up the maintainability index, right? So if you're going through scanning a code base, you can start looking at the maintainability index. If your goal is just, hey, I need to improve this code, and I'm going to start by looking for anything that's red. And then from there, you start going like cyclomatic complexity, and then eventually get to your lines of code and you figure out how big a problem you're actually dealing with. It's not going to tell you if it's readable, documented, or understandable by a human. That is not understandable by a human, in case anybody wanted to know. It's not going to tell you whether the code itself is actually bad, or it's just doing something complex. You could end up with complexity that's just a lot of left-right code, and that just might be what's needed to actually get the job done. But yeah, that code is not necessarily bad. It's just complex. So, how it works. Are you ready for the math? This is the formula that Microsoft uses to calculate maintainability index. So,
So in theory,
As a code, is that executable code or source code?
so as far as I know, when I'm looking at the documentation, it said lines of code. So, I don't know, it'd be interesting to see the difference between lines of code and executable lines of code. Although you're trying to determine the maintainability of the code base here. So then it might make sense to include comments and comments and blank lines and things like that, even though comments can be lies.
did they come up with this through a regression? Because just looking at some of these arbitrary factors like 171, it almost feels like a...
So the last part of that is to normalize, or to fit the number that gets cranked out between 0 and 100.
Okay.
Right? So 0, horrible maintainability. 100, excellent maintainability. Right? So, but if you have an arbitrary number like 171, I think is what it would be otherwise if they weren't, trying to fit it between 0 and 100. It really wouldn't. I don't think it makes as much sense as 0 to 1, a scale of 0 to 100. So.
What do we do on Sunday when we just rescale to 5.2.2 to 16.2? So just one line is. Like if you divide everything by 171.
We have a few magic numbers.
So instead of having 4 arbitrary numbers, you can have 3.
So I wasn't there when they came up with this, but I like it.
Should ask them to be part of the meeting.
Yeah.
I think probably they came up with these numbers from their own code basis.
Yeah.
Probably they derived some certain constants.
That's what I was thinking, it was like a regression based on like some source data, just because you see the weights on everything. And yeah, I'm speculating.
Yeah. Believe it or not, Microsoft just so happens to write a lot more code than I do. And they also have more people that can actually stare at this, figure out what makes sense. So.
But I wonder if that changed after GitHub. All the code on GitHub, did that change their constants or not?
I don't know.
Probably use GitHub. It's part of the-
Oh, that's
Probably,
the source.
probably use GitHub.
No, there's a data scientist somewhere, probably an entire team of data scientists.
Well, I think this came out even before GitHub was something. Visual Studio used to have this, I think, a long time ago.
So it was at least there in 2013. So it was before that. I would not be surprised if so when I was looking this stuff up, a lot of these metrics seem to kind of come about in the late, like mid-90s to early 2000s. So I don't think this one goes all the way back to like 70s or, real old school programming.
Because you get some very large lines of code just because I'm lower level languages, so I'll kind of throw the metrics off.
Possibly.
That's cool. I like this.
So, Maintainability Index is a useful thermometer, but you got to check why the patient has a fever, right? And this code base has a fever, the plague,
COVID.
COVID.
I think I went over on the way to.
Yeah.
It's a hospital.
This is very sick code. Okay. What's the one that came out of Africa that makes you...
Ebola.
Ebola, yeah, that's it.
But that kills you really fast, so.
Yeah.
It's like more of a slow, painful death. I think not quite as.
They got the measles.
So it might be more like a cancer.
There you go.
I mean, some stuff moves... Okay, anyway, we're not talking about that tonight. But all right, code churn. So this is going to be really handy. And you're basically... Let's go through what it is. Measures how often code changes over time. So typically you can kind of figure out what code churn is from like pull request to pull request or commit to commit kind of thing. And it's basically, you're just looking at changes to your code over time. So, and the way I understand it, you have some that, it's not just looking at, you're not just looking at like code churn in a project. You're looking down to like specific methods and classes. All right, so it's going to show you classes that are rapidly changing. And so lines added, modified, or deleted over a time window, like I said. So if you have high churn in a short time, it's going to suggest instability or lack of clarity. How to read it, higher numbers over time suggest instability or lack of clarity, like I was just saying. Lower numbers suggest stability and clear purpose, right? So chances are, like a constructor, like the way I was writing them in the code, the constructors, you write those once, right? You're just passing in some basic dependencies, and that might be all the changes that are ever made for the life of that code base, right? But any methods in there, like there's a series of methods called merge, and that's going to change because you're going to actively go in, you're going to be refactoring it and trying to get it right, right? And if you're doing that over multiple commits, that's going to introduce code churn. So what does it tell you? Signal for technical debt. It's going to tell you that code that's hard to get right or not well understood, right? Because if you're constantly seeing changes to a method, either it wasn't well defined what was supposed to be getting done, or it was not done correctly in the first place. It can also suggest areas for extra test coverage beyond what you already have, or it might just suggest a refactor if needed. It's not going to tell you whether changes were necessary or productive. So it could be, you can see code churn in the case where, like some of these open source projects, where people get on and they go through, they pull the code base down, they run a code formatter on it, and then check it in, you know. So they're not actually really changing the code, they're just kind of reformatting the code, but that's going to show up in the, as you know, additions and deletions to your code base. So that's going to look like your class is changing for a reason. But I'd argue just reformatting the code is not necessarily unnecessary or productive change. Yeah. I can tell you if it's related to, is due to iteration or a decision. Yeah, and there you go. You have a classic tug of war between one person or a team, 15 users.
As I have code reviews, it's bound to be changed. Kind of depends how many code reviews it class had.
Yeah.
It's like how many developers utilize this class. The more they improve, the more it's changed.
That's another good point. It could also show you that, hey, too many people have access to this one code
It's
base.
single responsibility, yeah.
And even like during the early part of the project, people are still essentially trying to figure things out and working on code because a lot of times, and it's a discovery game.
Yeah.
I mean, say this is good for like a code base that's been around for long enough to where that kind of sort of, becomes, kind of like a rounding error, right? So,
Yeah.
but early on in the process, it's good to
Yeah, because code churn, I'd say, is not good, not necessarily good at the start of a project, just because typically you're making bigger changes at that point.
Yeah.
Where you want to see the code churn trend down is the longer the project goes on, right? Hopefully you're writing smaller amounts of code, doing small bug fixes here and there. You're not just, checking in these giant commits where you remove 100,000 lines of code.
Right.
So,
Yeah.
So how it's tracked, you can track it, like I was saying, through Git commit history, also PR, diff analysis, and there's different ways you can visualize it, heat maps, developer impact charts. So the takeaway here is churn helps you spot code that's noisy, not always broken, but worth a second look, right? So if you're doing a code review and you have this metric gets shown to you, hey, this method has high code churn, that might be something you definitely want to make another pass at and do a sanity check before you just commit all that in. All right, I like this one too, code coverage, because typically when I'm working on a new, well, let's go through what it is and I'll talk about it. Just because it's touch doesn't mean it's tested. So, this is the amount of your code by percentage that's covered by unit tests or integration tests or performance tests, whatever kind of test you want to call it. So there are common types. There's line, branch, and path, but pretty much in Visual Studio, I think we pretty much just use line. And then how to read it. So higher percentage is good, lower percentage is bad. All right, so what it's going to tell you? It's going to tell you whether tests are actually exercising your code, right? You can tell that, hey, somebody has written a test or has written at least one test, and when it gets executed, the execution goes right through this particular method or property or what have you. It's also going to reveal unreachable or untested code, although I'd argue that other tools like, I think Visual Studio might, no, I'm going to say it's ReSharper, because I know ReSharper will actually flag code that's unreachable. That's pretty handy, especially when you're trying to get things kind of situated and ready to commit, trying to clean everything up. If it just flags stuff that's just unreachable code, it's easy to go in and clean it Yeah. Helps you set baselines for test expectations. What it's not going to tell you is whether the tests are good, meaningful, or asserting. So you can write a unit test and not include any asserts in it over a particular method, and as long as it runs over that method, it's going to say it's tested. But your unit test is dog crap if you're not asserting anything, right? It's not going to tell you whether, in fact, none of these code metrics are going to tell you whether any of the code you're actually writing is correct or bug free. And it's not going to tell you anything about what you've actually tested. So in some cases, that's going to be very important because you'll end up with edge cases that can result in bigger bugs later on. So the takeaway for this one is coverage is a flashlight. It tells you where the darkness is, not if the light's actually helpful. So let's see. Let's go back here. Oops. Is that down? So I'm going to show you the. We're going to use it back. I'm going to show you guys. Come on. Okay, so we're using InCrunch here to basically go through and generate our metrics for us. Right? If you're not familiar with the InCrunch, I like the tool. It's good. It's a continuous test runner. So you basically install it. It runs in Visual Studio, or they also have a version now that runs in Writer. And it continually runs. Depends on how you configure it. You can configure it. But typically the way I configure it is to run any tests that are impacted by any change I'm making, right? And what it's going to do is it'll generate some metrics for us. So let's bring that up. So over core, oh, come on man, run. I have to get out and push. Come on, dude, you're killing me. Okay. I'll have to figure out what's going on with it later. I don't, you guys don't want to sit here and watch me pull my hair out over this. But anyway, so if you look over here, this is the code coverage column, and this is going to show you the percentage of code that's covered by unit tests. So I believe the core project, right, has about 70 or 80% coverage, I think. And then, yeah, I really wish that worked. That would have been really good. All right. Now this one is neat. I came across this one while I was actually soliciting feedback for putting this talk together. Cognitive complexity. How much brain power does this code drain? So the class that we're poking fun at is the cyclomatic complexity over 9,000. That one has very high cognitive complexity, because that's going to require a lot of brain power. So, code readability metric estimates how difficult code is to understand. So, unlike cyclomatic complexity, it considers how nested and mentally taxing structure is. So, we're going to go over how you actually determine what cognitive complexity is. And it was originally introduced by Sonar source to improve on limitations of cyclomatic complexity. So I believe you can get this, cognitive complexity via a Sonar source product that runs in your CI/CD pipeline. That's one way to do it. Another way to do it is use Writer. Matthias, Koch, that's a German name, I think. Anyway, he's written a plugin for Writer that will actually show you the cognitive complexity, and I'll show you that in a second. So higher values, it's tougher to understand. Lower values, easier to understand. So it's going to tell you whether the code is easy or a brain pretzel, or you need to leave the company in the case of the code metrics we're looking at. So it also helps point out some code smells. And
Quick question. So does it consider any form of recursion code smell, or only necessary ones?
so this is not going to tell you anything about the context for why you wrote the code you wrote, but you're just going to be looking for, if you have recursion, that's going to drive your cognitive complexity up.
Okay.
So that's going to flag that, hey, maybe you ought to double check what you're doing and see if you really need to use recursion. I guess.
Got it. Yeah, that's also what I just wondered, because it's kind of interesting, just because the functional programmers wanting recursion over loops. It's kind of interesting that it's considered.
In some cases, recursion would be better for understanding as well.
Yeah. I mean, there's some problems that you can only solve with recursion, right? And I'm sure there's a bunch of stuff on HackerRank where, yeah, you can solve this particular problem with recursion, but you're going to get just a horrible big O notation for on the performance, and if you do it differently, your code, I'd argue, probably doesn't look it's probably not as easy to read. Because once you understand what recursion's doing, it's pretty simple to kind of put two and two together with that. But usually the recursion, especially for newer developers, when you just tell them, yeah, recursion, it's a method that calls itself.
Without an exit condition.
That's just called an infinite loop. But,
It was harder to use as traces.
or actually, not an infinite loop, stack overflow.
Exactly.
Yeah, so an infinite loop would be like a for loop or
A while loop.
while loop, while true. That's an infinite loop. Yeah. All right. So what's not going to tell you whether or not your code is logically correct? In case you didn't notice, none of these code metrics are going to tell you whether you actually wrote the right code. So that's a problem left up to the users to figure it out.
Up to LLMs now.
Yeah. So not going to tell you anything about the complexity. It's not going to tell you if the complexity that you're using is necessary to the problem to solve the problem. And it's not going to tell you whether your variable named A is a good name or a bad name. It just knows, hey, there's a variable A. It doesn't say anything about comments or even design patterns. Although I'd argue, refactoring the design patterns can make things easier to understand, because design patterns kind of give us a common language that describes functionality in code, right? So how it works, 1 point per control structure, plus 1 point for each level of nesting. So that's like if you start doing, you could probably blow up the cognitive complexity if you have a bunch of nested if-then statements, right? You know, like the ones that, I heard this actually referred to as like a Hadouken, it was called Hadouken something. And it was basically because the way the code was written, all the if-then statements had caused the code to shift over in the editor. So you get one point for recursion instead of loops. And there's no penalty for multiple Boolean conditions in the same if.
So you can have like if a very complex condition.
Doesn't look like it. So the takeaway, cyclomatic complexity counts the paths, cognitive complexity counts the headaches. Right. So let's switch over to writer, and we'll go through. Okay, so now let's go here. I want to start here. Let's look at our external merge sort. Okay, so for this merge method, right, which is what we're going to look at in writer, it has a maintainability index of 45, which is still good. Not great, but still good. A cyclomatic complexity of 14. Okay? But over here in writer, it tells you that the cognitive complexity value, is a complex, composite, let me try to get it in English.
A little cognitive complexity going on right there, huh?
Yeah. So there's cognitive complexity value of 26, which is 200%, 260% of the threshold of 10. So that's where cyclomatic complexity is going to vary from cognitive complexity, right? So cyclomatic complexity tells you, well, this code is not that bad, but the way the metrics are set up for the cognitive complexity suggests that, hey, this is going to take a little bit to understand. And I don't know if it's influenced by all the different comments I left in there, but again, this is 2013 code. All right. So now we're winding down here. Does anybody know the only valid metric of code quality? Okay? It is WTF's amendment.
Oh, yes. I remember seeing it.
I love this cartoon
Yeah.
because I've been in a few of those. I've been on this side a few times. I didn't like it, but this is perfect. Good.
Apple there's 2 WTF on the left and there is 6 on the right. Okay, 5.
So, well, I'll tell you,
Per minute, okay? Yeah, per minute.
I would argue that these meetings are a lot more fun, and they're typically a lot more funny than these, but this is what you get when you deal with that 9,000 cognitive complexity class with over 9,000.
Suppose unique WTF over a specific line of code or specific block of code. Because if just says several times about single line of code. Yeah.
I love the idea of formalizing this metric. It's got a nice little equation.
The only problem is that you can't actually, you can't regenerate it, right? So this is going to be kind of a first exposure to the code that's going to cause this.
Yeah.
Then you get used to it and it will be less expressive.
Well, you know, the thing is that once the initial shock wears off, you know, the WTFs per minute should go down. Right. So, it's when you see this stuff for the first time, that drives the WTFs and metadata.
Then you'll like, you don't have expectation when you see it first time, then when you see it,
Yeah.
you'll align with your expectations.
Yeah. Or you could be looking at just some really gnarly regular expression stuff.
Yeah.
So that'll make you scratch your head some too. It's amazing what you can do with regular expressions though.
It is, but the net results, I'm trying to debug them.
Debugging them is not fun.
Yeah. Well, but if you have good unit tests, it makes it easier. But, you know, depending on who wrote your code base and who brought that regular expression in, you know, it'd be just somebody just generating technical debt for you.
I have a bad habit of using regular expressions simply from code coverage.
Yeah.
Instead of a branch, just use a regular expression to come out of branches.
You
It's a
know-
bad habit, but it improves the benchmark, I guess, so recently. So it's your, that you already said at the very beginning.
Yeah. Well, anytime,
If I use the coverage mentioned.
it's a good habit as a software developer. If you're writing code and you find yourself in one of these cases where you're writing some code that's just going to be difficult to understand, leave comments, right? Leave it. Try and leave a breadcrumb trail for somebody who's got a volume.
Or for yourself in 2 years after that, something like that.
It might be 6 months. It could be.
A week.
It could be over a weekend.
Once they made it.
So, one of the things, a good way of doing software development is if you need to write your code as if the person who's coming behind you to maintain it is a violent psychopath who knows where you live. Right? So, this one might get you attacked. This one, you know, you might just get dirty looks from, you know, kind of thing. All right, so some to-do stuff, all right? Collect metrics on your projects, all right? If you're starting work on a new project, you know, change employers or something like that, collect metrics on the code base before you start working on it, all right? And the reason why you want to do that is because when you roll off the project, leave that employer or something like that, capture the metrics again, and you can kind of get an idea of what you or your team's impact on that code base has been. It's pretty interesting. And I thought I had some, so this code, I seem to remember kind of doing a before and after. And I had knocked down a bunch of these numbers. I had gotten it a lot more manageable. Like I had changed like the top 3 methods and the lines of source code. I think I reduced it by like 20,000 lines. So very proud of that. You know. So, and the reason, other reason why, two reasons why you want to keep it is you can use it on your resume. Right? If you're going for a technical job, right, and you can say, why should we even hire you? Because I, you know, removed so much cyclomatic complexity. You're doing more with less. Okay. And you can also use it as a talking point in your interviews, right? So if you don't put it on your resume, right, if it doesn't fit there, if you have an interview where you need to talk to developers, managers, people who make the hiring decisions, you can talk about that, because that's a win, right? So that's a metric wrap. So metrics tell a story, but they don't tell you the whole story. Interpret the numbers, but don't worship the numbers, right? Because if you start worshiping the numbers, like if you just decide lines of code is going to be the metric that, and the hill I'm going to die on, it's not going to work. It's not going to end well for you, I guess. Because So you want to use metrics to guide decisions, not dictate them. Focus on trends and context, not snapshots. And your code is more than just numbers, it's a graph. All right, so anyway, how to contact me. There's my email address, there's my blog, and there's my LinkedIn. And if you want to add me on LinkedIn, you can take a picture of this QR code, and I'll get it. So something else I want to point out on here, this line right here. I am looking for a new job. If you have any referrals you wouldn't mind sharing, I would appreciate it. Any questions at all?
Kind of. Lots of, I'm sorry, what?
That was a question for another country.
Okay.
Code locality.
Cardinal?
Code locality.
Code locality. Okay, what's that?
So you count the number, like the classes. Well, like you have a UI subroutine, and it calls a bunch of classes or functions in another class or another function that's in another file.
Yeah.
So it counts, instead of counting class company, it counts file company. So all your code is in one file, and your brain doesn't have the context switch every time you have to jump to another file.
Yeah.
And you're trying to understand the function.
Okay, I'll look into that. I got to give this talk at, next month at the North Houston.net user group.
So instead of having a bunch of subroutines in a bunch of different files,
Yeah.
it's called Nifro, which gives you a headache.
Yeah.
You just have all the subroutines locally in application.
Yeah. I'd argue that's a good approach, especially if you have a bunch of methods that are being reused all over the place. You know, because then if you have code that's being reused all over the place, it might make sense to break it out. It's more commonly known. But I'll look at that code Cardella.
Code locality.
Code locality. Okay.
Like hash locality.
Okay.
So kind of, I guess kind of question, but also kind of suggestion, or what do you think? So have you thought of like what do you think of incorporating something like fuzzing into like test metrics? Like, cause you got code coverage. I remember you were talking about how, people can have tests that aren't at all meaningful, expect true to equal true, that kind of stuff, right? But then you have like techniques like fuzzing, which will automatically go through your test and like perturb them a bit and see if they still pass, which lets them know that your test condition was way too loose or even not meaningful, right? And I don't really know if there's any metric necessarily that fall out of that, although in theory there could be, like in terms of meaningful tests. And this code fuzzing is something I don't know is used terribly much in, but just like what your like read on that is, what your thoughts are.
So I've heard of that, right? And just like you said, gently massaging the data that gets passed into your unit tests. That makes sense, right? Because you're just doing durability checking on your code at that point. But it's not going.
Or even a test themselves, like a test condition of like what you're expecting, and then you're like, yeah, you massage like whatever's like asserted in that test, you massage that data a little bit, and like, hey, this still passed after massaging. And again, it may not tell you that you're testing. It could be the test is meaningless, but maybe you're testing for something greater than some value. Well, there's a broad range where you can jiggle that, and it's still going to pass, right?
Well, so you're talking about like cases like, all right, so the input for the method should be, the number 10 or less. So you could just test with like 11, and that should fail, right? But what if you try and pass in like int max kind of thing?
Right.
Is that still going to pass, or is that going to blow up?
Right. And yeah, and generally it would be that any test that's too permissive, including absolutely meaningless ones where you just expect it true to be true. You're like, hey, wait a minute, this is not a good test. We're able to, perturb the condition and the test still passed. Flag it and say, just something kind of like as part of code coverage as well, at least could tackle that as an additional metric, could tackle like the number of tests that aren't particularly meaningful. Like it's like, hey guys, it's really great code coverage. Most of these tests aren't particularly meaningful. Maybe metrics that fall out of fuzz could at least give you like, hey, how many of these tests are meaningful for your 90% code coverage?
Yeah. Well, so if you're just thinking, if you're unit testing code that's complex enough, just changing the inputs is going to change what actually executes. So what you would see is a wildly varying code coverage, I would expect with that, right?
Right, your code coverage would vary. In this case, it would be more like for all of your tests, you know, I have 20 tests, right? And if I perturb the data on those 20 tests, how many of those tests that were all passed, that should all be passing, are now failing? If like none of them fail, you're like, wow, these 20 tests, probably not that great or not that tight, right? Just something to maybe kind of judge quality of specific tests. You wouldn't necessarily, so it would be something you have in addition to code coverage. Like here's your code coverage, here's a list of tests, you know, that we found that don't seem to be very meaningful. Just because something kind of used in conjunction.
Yeah.
And it's purely speculative. I'm just wondering your thoughts on that.
So I would say, all right, when I write a unit test, I want it to work the way that I want it to work, and I want it to always work that way, because what I'm trying to detect are breaking changes in the code base that I'm actually writing, right? So that kind of fuzzing kind of approach, that sounds like something you would do in addition to unit testing.
Yeah, oh yeah. You basically apply it to your unit test in a way to kind of to at least catch out the people who are trying to like cheat the metrics, for example.
Well, okay, so let's.
And again, that's whole the topic of people who try to game the metrics, right? Like you said, when the metrics become the targets.
Yeah. So the trying to think what would be a good example of that. All right, so for example, this good output file test, right? I want that to always pass, always work, right? Because I want to know if I pass in an expected number of values 10, that it's not going to throw an error message, or not return an error message in this case. So,
Yeah, so like a fuzzing, for example, may go like say to that line where you know SUT validation and it will say, hey, validate say 50 or validate say 11, right?
Yeah.
And then say, hey, are we still, is that line a certain null still passing, right? And then at least we'll try to get a read on like, hey, how tight, how specific that test is.
you know, another way you can do it is you could add a parameter, right? And you do parameterized unit tests.
Yeah.
So you would do something like,
That or even like in the theory section where you added all of your data that gets fed to a test function. And that's actually a cleaner way of doing it because then you know what's going to feed to the test rather than trying to say, which line of code does it? Absolutely. It's actually a much better way of doing that.
yeah, so you do expected numbers,
Yeah.
and then theory 10. The theory 10?
It was something. It was what was it theory? It was some tag where you could add like inline data. I don't remember what the tag was, but I know what you're talking about. You can add as many as you want, and they all get fed into
Theory. It's
a
theory and
inline
inline.
data.
Okay. So just change that to be theory. Oops. Theory. Just to type it on an angle like this. So there you go, 10.
Yeah.
So you could do that.
Right.
You know, you could even do. Yeah. Come on. So you could do something like that, you know, and test edge cases.
Yeah. Yeah. And yeah, for like the edge case too, like the edge case test was like property-based testing could be something that's good for that. And that's where it's actually just going to generate all of your inline data like randomly, but the really good engine should give you edge cases. But yeah.
So just to show you all the unit tests actually work. Run.
Yeah, I've noticed sometimes running through the test explorer, sometimes you just won't run your test, and sometimes you just have to like restart it. And I found it happens like more with like, I think like XUnit I found tends to be more reliable as far as the test running, but I've had this happen actually before. And when I was actually hit right, like it would not be running test, it doesn't restart the project. Yeah.
I'm sorry, I don't know what's going on with that, but I'm gonna have to figure that out. Because that would have been a good demo.
No, I think it's like it's a bug I've noticed for a while because I've had it happen to me too. You just the test runner will sometimes just not run your test. It's like you just have to restart your project.
Yeah.
That thing will cause them to run sometimes. It's yeah.
Well, I mean, I updated all the software right before the talk. So except for InCrunch, I didn't actually update that. So maybe I ought to go through and update that.
I'm sorry. What other kind of question? And so, of course, we don't want to worship the numbers. We don't want, we obviously want to, context is king. But just out of like morbid curiosity, are you aware of anyone who just as an experiment, for grins and giggles, whatever, decided, hey, I want to write, say, maybe a 10,000 line program, something not terribly large, not terribly small, and just, but I want to basically like use nothing but say metrics to drive the changes I make, just to at least see where I land. Do you know if anyone's done any kind of like sort of experiment like that? Just
I don't know about experiments. I know I've done that with, again, that monster. With this, I did that, right? That's how I was able to cut off like 20,000 lines of code, simplify the code a whole bunch. Because I was, when I saw what well, first of all, when my computer bogged down just trying to open the damn file, that told me, hey, there's something wrong. And you go look at the code metrics. Oh, we have a 61,900 line problem. And then, you just start digging into it, right? So,
yeah, because using like all those metrics, like just saying, hey, like those 6 months, like, hey, I ate nothing but lentils for 3 months is what happened. It's like, hey, I wrote this code with no considerations other than optimizing, say, these 8 metrics or whatever, and let them just drive what I do next without any kind of concern for what I know about good practice, just to see what my code looks like. Just kind of curiosity. It's kind of interesting.
you have to remember that perfect is an enemy of good enough.
Oh yeah.
Right? So, and software is never finished. It's abandoned.
Yeah, it would be just one of those things where it would be interesting to see, like, how does experience feel? What do you feel about the measure before and after? And of course, at some point, you're going to be like, hey, at the end of this period, or just at the end when I hit at least these revising these metrics, we kind of stop and just see what it looks like.
Yeah.
I'm kind of curious because it is having all these metrics is nice, and of course, you have to take care with them. But it's good to at least know that people have given enough thought to these and understand some of the trade-offs, and that you at least have some tools to help guide you.
Yeah, well, and this is where where you're just, when you're worshiping the numbers kind of thing, you can just deflate the morale of a software development team, right? If, because you're just kind of, I'm trying to think the right way to say it. You're basically doing like a limbo test for the sake of just having a limbo test.
Yeah.
Right? Because you have to remember, at the end of the day, it's the most important thing is whether or not the code works, right? Because you have a business that's trying to make money off of what you're doing, right? And if you're just trying to hit metrics, like this, that's time. It's not necessarily a good use of the company's time and money to do that. Right. So, but I would argue as a software engineer, you want to have high code coverage numbers, if you can. It doesn't have to be 100%, but maybe something like the 80-20 Pareto principle, right? So,
Yeah, because we're trying to aim for like, reducing, like cost of ownership, and the thing is like what, because at least that's what's going to matter is bottom line to the folks who basically trust us and pay us to use software. It's like, well, this is going to be like, and we're kind of using some of these as proxies for like, well, right, readability metrics should be more maintainable, should be cheaper for the company, that sort of thing. Absolutely.
yeah. So it's, like I said, I was saying at the beginning, it's the code metrics. It's not binary. It's not good and bad. It's multidimensional, right? Well, it can be kind of good in this way, and kind of bad in this way, and there's a certain amount of goodness and badness you accept. So, but I would say you should always try and write that code, because the person following you is a violent psychopath who knows where you live. So. Anything else? Okay.
Cool. Thank you. Well, thank you very
Thank you
much.
for coming.
Thank you very much. Really great talk.
Yeah, it was very thought-provoking. I'm just thinking about my scripts, although I'm sure this is more intended for stuff more complex than someone automating ETL, right?
Yeah. Oh, I was going to show you, I skipped over one of my little demos I was going to do. I was going to show you code churn on Advent code project. So this shows you code churn, right? This may not be the best way to do it, but this just shows you at a glance that I was mostly committing, adding code, and there's a little bit of code deletion in there. So, and just from when I was working on it, so anything that occurs before December 1st, that's me just getting the Python project set up, kind of the setting up the way I'm going to actually write the code. Because I'm trying to set myself up so where when I come into the next problem, all I have to do is just solve the problem and not worry about writing any of the mechanical stuff to unit test it and things like that. And then here, this is where I'm working on specific parts of the code. And then right around here is probably where I gave up because I got tired or ran out of time to work on it. And then here's when I suddenly had more time to go through and finish the rest of the code questions. So, I'd argue if you're trying to learn a new language, Advent of code is a good way to do it, right? They give you some pretty complicated questions. And if you need to, you can go and you can look things up. It's not locked down like like a hacker rank or leak code kind of thing where you get penalized if you switch browser tabs and that kind of garbage. But it gives you a more real world. It gives you a real problem, I guess, and not just leak code, because you have to figure out how to solve the actual problem, and then you have to figure out how do you actually write it. Then you have to figure out what little twist they put in there that's causing your code not to work. So, but
even like the scripts that you're writing, if they're anything above just like a few lines long, some of what's mentioned here still could be useful, right?
Yeah.
That's the conditionals, anything like that. So it's surprising that there's almost no code so short that it can't benefit from a little bit of
Right.
So there's one of my, this was the solution I did for the 20th, 2024. And just looking at that code makes my head hurt, because I don't write .NET code like that, and that's kind of my daily driver. So you have to make a little bit of a mental shift. Anyway.
Very good.
Cool. All right, that's all I got.
Do you, it's only up to you, like the, do you have like a presentation? Do you feel comfortable like sharing it or sharing any, like anything like on GitHub or anything? Like, you didn't have to, I'm just wondering if anyone's interested in that.
So the presentation I'm going to put up on my blog.
Oh, okay, cool. If you want to give the link, I can like put it in the
Yeah.
chat to your blog.
Yeah.
Just to remind everybody. Cool, yeah, no, that's fine, just so, because yeah, there's a lot of good stuff there, I know.
It's released on December 24th at 11 p.m. And they're typically structured as 2 problems back to back. You know what? Let's go look at a problem. So here, you know, there's a story that it goes through, and whether or not it adds anything to the actual problem you're doing, kind of debatable, right? You gonna ask something?
No, that looks like really old text game or something like that.
Yeah. But, you know, they give you input, they walk you through some examples on how to do it, or what the answer should be, what you should get. And there's 2 parts, so you come up with the answer to that particular problem. You put the puzzle answer in, and if you're good with part 1, it's going to unlock part 2. And then you do part 2. So it's just 2 problems a day, and every day, when you get the stars, you get, for each problem you solve, you get a star. So I solved all 25 of those, and so I've got 50 stars. And
Not adding any more problems?
what's that?
They stopped adding problems?
Yeah, because it's Advent of Code. It's a Christmas
Oh.
type of thing.
So each year, okay, you can use any programming language, I suppose.
So here is, yeah, these great cats. So this is this is for the company I did work at, right? Where we kind of, every year around Christmas, there's a big push to get all the software engineers doing this, right? And there's various levels of support. People have different levels of time available and things like that. But you can see, you know, some people just make the first problem. A lot of people don't make any. So
Oh, that's...
I think there's also a bunch of people who have probably left the company at this time. So that doesn't make sense. Yeah. So this was just this is everybody in the U.S. who was signed up to do Advent of Code this year. So,
We have different 25 problems every year.
yeah, and they're different. Well, so the problems are the same. The inputs are different from person to person. So you can't just, you know, go find a solution and, you know, all right, here we go. Here's the answer. It doesn't work like that. You got to actually, you have to have code that actually runs and actually solves the problem. And
You
it's
cannot use somebody else's code because your input parameters are different and therefore different. That's how they, I guess, control cheating.
well, it depends on how the code is written, right? If we're tightly coupled, right, the inputs are tightly coupled to the actual implementation of the code. It's going to be tougher to get the answer, right? If it's released on December 24th at 11 p.m. And they're typically structured as 2 problems back to back. You know what? Let's go look at a problem. So here, you know, there's a story that it goes through, and whether or not it adds anything to the actual problem you're doing, kind of debatable, right? You gonna ask something?
No, that looks like really old text game or something like that.
Yeah. But, you know, they give you input, they walk you through some examples on how to do it, or what the answer should be, what you should get. And there's 2 parts, so you come up with the answer to that particular problem. You put the puzzle answer in, and if you're good with part 1, it's going to unlock part 2, and then do part 2. So it's just 2 problems a day, and every day when you get the stars, you get, or for each problem you solve, you get a star. So I solved all 25 of those, and so I've got 50 stars. And
Not adding any more problems.
what's that?
They stopped adding problems.
Yeah, because it's Advent of Code. It's a Christmas
Oh.
type of thing.
So each year, okay, you can use any programming language, I suppose.
So here is, yeah, these great cats. So this is the, this is for the company I did work at, right? Where we kind of, every year around Christmas, there's a big push to get all the software engineers doing this, right? And there's various levels of support. People have different levels of time available and things like that. But you can see, you know, some people just make the first problem. A lot of people don't make any. So
Well, that's,
I think there's also a bunch of people who have probably left the company at this time. So that doesn't make sense. Yeah, so this was just this is everybody in the U.S. who was signed up to do Advent of Code this year. So,
There are different 25 problems every year.
yeah, and they're different. Well, so the problems are the same. The inputs are different from person to person. So you can't just, you know, go find a solution and, you know, all right, here we go. Here's the answer. It doesn't work like that. You got to actually, you have to have code that actually runs and actually solves the problem. And
you
it's
cannot use somebody else's code because your input parameters are different and therefore different. That's how they, I guess, control cheating.
well, it depends on how the code is written, right? If we're tightly coupled, right, the inputs are tightly coupled to the actual implementation of code. It's going to be tougher to get the answer, right? If it's